Algebra 1, Lesson 77. 2 parts. Nothing too horribly difficult. We talked about consecutive integer problems where we were trying to find 3 numbers in a row that met certain criteria. We're going to add a wrinkle to that. This time, consecutive odd integer problems. Only difference in this. Let's just draw a number line so we can imagine this. Okay, so let's just start in the middle. Squeezed a bunch of numbers onto this. If we are talking about consecutive integers, not even or odd, the way we did it before, we would say, okay, let's let the first number be n. Let's say that this is the number, and then the next number would be n plus 1, and the next number would be n plus 2. That's 3 integers in a row, consecutive integers, right? But now we want to talk about even or odd. So let's start with even. 0 is an even number. If we want the next consecutive even integer, we would add 2, right? So our first number is n, just like we did before. The second number, instead of being n plus 1, this is for consecutive. If it's consecutive odd, I'll explain that too in just a minute. The first one is n, but then we do n plus 2, right? To get from 0 to the next even consecutive integer, we would have to go up 2 jumps. And then from there, we'd have to go up 2 more, so that would be a total of 4. Does that make sense? Okay, so with just consecutives, we can take the number plus 1 plus 2, because that gives us 3 in a row. But if we want evens, we have to do every other. So we have to go up by jumps of 2. Now, many students think, well, you can't use the same pattern for odds, but guess what? It's exactly the same pattern. Let's start with 1. The next odd number is 2 jumps away, 3. The next odd number is 2 more jumps away, for a total of 4. That gets us to 5. So this pattern works for even or odd consecutive integers. This is what works when we're just going one by one. Even or odds, we have to skip every other number. All right? So the only thing that's different in these problems that we're tackling now is that our pattern for setting up the variables changes slightly. So let's do the first example. There are 3. Example 77.1. Find 3 consecutive even integers such that, oh, look how crooked, the sum of the first and the third equals the sum of the, no, I said that wrong. Never mind. I need to write down my variables because I'm getting distracted. As soon as we read that we're finding consecutive even integers, we know it's this pattern. N will be the first. The second will be n plus 2 because we'll have to jump over. The third will be n plus 4 because we'll have to jump over twice. My pen is actually jumping over. It was out of camera range, so you couldn't see it. Okay, now we can listen to the dramatic, crazy explanation. Find 3 consecutive even integers such that the sum of the first and the second, okay, so the first is n, the second is n plus 2, that's the sum of the first and the second, equals the sum of the third and minus 10. Okay? Do I need to put these parentheses on? Well, as we can see now, there are no minus signs or multiplications, so we can take them off right away. I like to put them on just to be sure that I'm not making any mistakes. Okay, so now, but we see there's no negatives, there's no distributions, it's fine. So here I'm going to combine these two, and I'm going to get 2n plus 2, and then here I can combine these. equals n minus 6. All right, let's bring the n's this way and swim the plane numbers that way. You cancel, n equals, let's see, it's minus 6 minus 2, that's minus 8. And so our numbers would be minus 8, minus 6, because we're adding 2, and then minus 4. Or box it and do that. Now, one thing I want to point out is that I didn't have to do anything to make sure that this turned into an even number. I didn't have to do anything to strategize to make this turn out to be an even number. The way the problem is set up will just get you to either even or odd for your first solution. Your job is only to set up the variables so that they will create the pattern that you want. Does that make sense? When it says consecutive even, you don't have to do anything to make your answer turn out even. It just will. Okay, let's do another one. And what's going to get harder is the way we set up the equations. This is the only part you really need to worry about. Okay, example 77.2. Find 3 consecutive odd integers such that blah, blah, blah. Let's set up the pattern first. The first one is going to be n, like all these. The second one is going to be n plus 2. Just because that's an even number doesn't mean it won't work for the odds. The odds are every other number, so we have to add 2 to skip up to the next odd number. And then the third number in our sequence will be n plus 4. So if we want to just wrap our heads around this, let's imagine our first number is 1, that's odd. The second number would be 3, 1 plus 2 is 3. And then our third number, sorry, I saw the 4 and got excited. The third number would be n plus 4, and is 1, so this would be 5. So 1, 3, 5. Yeah, that works. That would be 3 odd consecutive integers. Okay, so we're all set up. The sum of the first and the third, so n plus 4, and again, I put that in parentheses just to be safe, is greater than, I ignore the number, the second, n plus 2, decreased by 18. Okay? Let me say it again. The sum of the first and the third is greater than the second, decreased by 18. Okay? So this isn't what balances it. That's we still have to balance it, and the number that we use to balance is 7. Okay, so this side is bigger. So I propose let's add 7 to this side to get it to balance. All right? So, simplifying, again, I check my parentheses to make sure there's no minuses, there's no numbers to distribute. I'm good. 2n plus 4 equals, and look, we can clump all that together. N, 2 minus 18 would be minus 16. A second, I'm not doing this the way I want to. It's minus 18 plus 9, so that would become minus 9. And now let's subtract the n and bring him this way, and we'll subtract the 4. I wasn't adding it in my head. N equals minus 13. And again, without us having to do anything to make it work out, we did indeed calculate a negative number. So our first number is negative 13. Our second number we add 2 is negative 11. And then plus 4 is negative 9. So there are our 3 consecutive odd integers. Beautiful, right? All right, last example in this part of the lesson, 77.3. Find 4 consecutive odd integers. Okay, we haven't done 4 before, but guess what? We just keep skipping over the even numbers by going every other. And there are 4 consecutive odd integers. Okay, the sum of the first and the fourth is greater than the opposite of the third. Oh, we haven't done this in a while. The opposite, you put the minus sign in front of it. And the third is n plus 4. Okay? This is great. Let me read it again and make sure. The sum of the first and the fourth is greater than the opposite of the third. And the number that it's greater than by is 25. So I'm going to add 25 over here. Okay? I could subtract it here, but I don't have room to squeeze it in, so I'd rather put it on this side. That's honestly how I decide. Okay, so now we can simplify. I can't just rip my parentheses off. I have to distribute that minus. But this side is fine. 2n plus 6, and I fix that so it's equals minus n minus 4 plus 25. Notice that this minus sign does not get distributed to this. It just gets distributed to what's in the parentheses. So he's still a positive 25. And so this I'm going to change. It's plus 21. All right. Subtract 6. Add n. Goodbye, goodbye. 3n equals positive 21 minus 6. That would be 15. Divide both sides by 3. N equals 5. Again, we didn't have to work to make this come out to an odd number. It just came out that way. So now my answer is going to be 5, 7, 9, and 11, which I got by just plugging 5 into all of that. And that's the right answer. This was the right answer too. Yay! Okay, that is part A. John, these lessons, they go on for weeks, don't they? Part B. Fraction and decimal word problems. Okay, we're into frickin' formula land. F times of equals is, or D times of equals is. Fraction version, decimal version. We're going to be working on some ice cream sundaes and some peanuts. So let's try 77.4. Lopez used a 5-iron, but the ball covered only 4/5 of the required distance. Okay, this is a golf drama. All right. If she hit the ball 112 yards, what was the required distance? Okay, this one, we can visualize somebody hitting a golf ball, and it needs to go that far, right? It needs to go this far, but it only goes 4/5. Okay, so this was the full distance, so we can assume, these aren't going to be even. 1, 2, oh no, I did that wrong. I divided it up into too many parts. Let me try again. Okay, 1, 2, 3, 4, 5. There are the sections, the 1/5 to the, this is the cup, right? The hole. There's the flag. Look, it's got a crooked flagpole. So she went 4/5 of the distance. She had 1/5 more to go. And it says if she hit the ball 112 yards. So this much of it is 112. What was the required distance? So we want to know what was the full distance here. Now, I can visualize it this way, but it takes a little bit of work to put this into a peanut ice cream, or no, not a peanut, an ice cream sundae style. So this is the full distance that she needed to go. And we're doing this with a fraction, right? But she didn't hit it the full way. She only hit it 4/5 of the way. And then this is the 1/5. So I'm taking this diagram, which is what appears in my head, and I'm making it fit into our typical diagram. And that takes a little bit of work in this one. So this was 1. This was the required distance. It represents 5/5, 4/5 and 1/5. she hit it 112 yards. We want to know what was the actual full distance she was trying to go. Does that make sense? All right, so we can take this and this version and make it work. We will use 4/5 times x, and I'll put it over 1, equals 112. We'll put that over 1 just in case we need it, right? Okay, to isolate our x, we'll multiply by 5 over 4, 5 over 4. Okay, I know that 4 will go into 112 because 4 times 100, or no, 4 times 25 equals 100, and 4 times 3 equals 12. So that tells me 4 goes into 112 28 times. Does that make sense? We could do it long division, but this is how my brain breaks it out. And then we need to multiply 25 times 5 to get what that full distance was, or 28 times 5, sorry. 5 times 2 is 10 plus another 0, because this is actually 20 equals 100. 5 times 8 is 40. I'm just showing you my mental map of how I can multiply things like that in my head. You might have your own way, that's fine. I'm just showing you how my brain does it, because you're not here to talk. So this is how many yards was the full distance. Okay? That one's tricky because it's easy to visualize this way, but it's harder to visualize that way. And then we can also figure out that if that's 140, then this must be what? 28? 0, yeah, that adds up to 140. So that's how many yards she was short. It's 28. Okay. Example 77.5. No, yeah. Mickabee guessed that the total was 30.24, but this was 7.2 times the total. What was the total? Okay, this is another one that's kind of hard to visualize. Here's some number that represents the total. Okay? And we can think of it as 1. She guessed a number too big, or he, I don't know. This number was 7.2 times. Okay. So, and the number she guessed was 30.24. So, we're going to call this x. This is the beginning number. This is the ending number. We know that this is a peanut style because it's bigger than 1. She guessed a number that was too big. So, 7.2 times whatever our beginning number was equals 30.24. I could have used WN for this, what number. I just chose to use X this time. So we divide both sides by 7.2. And let's just do this long division old school. What's the rules for dividing by decimals? Oh yeah, if there's one out here, we have to jump it away. And then we have to jump that one away, and then we put the decimal up on top. Okay, I'm just going to guess by using my lead number instead of both of them. 7 into 3 doesn't go. 7 into 30 is 4 times, but I have to make this over here so I have room to multiply this one. 4 times 8, 2 is 8. 4 times 7 is 28. Okay, so that lined up the way I wanted. I subtract. This becomes 29. There's a 1. 1, 4, and then I pull down 4. 7 into 14 goes twice. Pretend that's lined up perfectly. 2 times 2 is 4. 2 times 7 is 14. It came out even. So the number, the original number, was 4.2, which is right there. That's a little bizarre. She was trying to guess the number 4.2. She guessed that number, and it was 7.2 times too large. So it was 7.2 of the original. Okay, let's try another one. 77.6. This is the last one. This one to me is a little bit, we can fit it into our framework a little bit more easily. 3/4 of the tickets had been sold. Okay, so here's all the tickets. And now we're going to divide them into sold and unsold. 3/4 were sold, so I'll put my line about there. 3/4 sold. This division problem is encroaching on our space, but it's fine. So 1/4 is unsold, right? Okay, I'll read it again. 3/4 of the tickets had been sold, and there were 420 tickets left. Okay, so this is where the 420 goes. That's not how many were sold, that's how many were left. How many tickets were printed? Okay, so we assume that's this. I'm going to write what number this time. So we have fractions. This represents 1. Once we figure out this number, we'll be able to figure out that number. Okay, so let me read it again and make sure it's right. 3/4 of the tickets had been sold, and there were 420 tickets left. How many tickets were printed? All right. Where's our freaking formula? I didn't write it. F times of equals is. We need to use this row of numbers because we don't have this number. So if we tried to use these numbers, we'd have two variables. But here we've got two pieces of information. So we can say 1/4 times what number? This is the of, this is the is. 3/4 times that number equals 420. I'll put that over 1. Here's our variable. We'll multiply it by 4 over 1. 4 over 1. We don't really need the ones, but it's fine. This is the format we've used. This cancels. 420 by 4. I know this much is 16, and this much is 80. So that's how many tickets were printed. And we didn't actually need that number to do this, because if this is 1/4, then 3/4 would be 3 times that number, right? So that would be 1260. Yes. I multiplied this by 3 and I got that. All right, so we can fill in all the different parts. These two add up to that, and that's the correct answer. Yay, that's lesson 77, 2 big parts. I will see you shortly for lesson 78, which is going to be faster.